All right. Well, thanks everyone for joining for another live office hours session. Uh, it's been a slightly more regular pace of office hours, I'd say, in the last few weeks as things have calmed down a bit in California. But it looks like we're headed for another fairly active week. So I think it's time for another conversation. Also, there is a lot of buzz about what's going on in the long term, or at least the medium term, depending on whether you're talking about weather or climate, I suppose, as relates to El Nino and the ongoing rapid developments in that department in recent days and weeks. So, what I wanted to cover today was the ongoing big melt, the major melting of the enormous snowpack in the southern half of the Sierra Nevada this year, which has rapidly accelerated in recent days. The relatively active weather this week across much of California, where a cut-off low pressure system is going to bring another round of much cooler than average temperatures, windy conditions, along with some precipitation, probably some localized thunderstorm activity, which could be notably strong in some areas, along with some high mountain snow. Not a lot, but enough to be notable given that we're now in May. And then as well, the transition toward the rapid transition from La Nina conditions in the eastern tropical Pacific Ocean to what are now rapidly approaching El Nino conditions, and the latest update on just how large that event might become. All right. So I'm going to start with the big melt because there were a lot of headlines about this last week, and we did have a significant early season heat wave late last week into the weekend with temperatures into the 80s and 90s in the inland valleys, and probably more importantly from a melt perspective, temperatures that were continuously above freezing even at high elevations in the mountains last week for the first time really since early last autumn. It's been a particularly long and cold stretch. So a lot of snow did in fact begin to melt, and runoff doubled, tripled, or even quadrupled in some basins. And although it's tailed off a little bit since then, the rates of runoff right now, as of this live conversation, are still a lot higher than they were a week ago. Residual effect of that net warmth. And the fact that the sun angle simply is getting stronger and stronger. So there's more and more melting of that snowpack going on whenever it's sunny. Not just because temperatures are warmer, but because the direct solar radiation is increasingly strong as we get closer and closer to the summer solstice. We're actually less than 2 months out from that now, so it's a strong May sun as of today, acting on that snowpack. There was no serious river flooding this past week, despite the warm temperatures and the rapidly accelerated snowmelt. There was some minor flooding locally, but in general, it was not so much of a problem in and of itself. The bigger concern remains not so much the rivers and streams in the mountains themselves. They might experience minor to moderate flooding again at some point between now and the end of the melt season, which again is going to last at least another month or two in most places. The really big concern remains the San Joaquin Valley and the Tulare Lake Basin. Generally speaking, the risk of serious damaging flooding in the mountains, the rivers, and in the foothills themselves, where the rivers have significant slope gradients, in other words, when you still have some topography to work with, and the slope of the watershed is steeper, usually the major flood events in these regimes occur when the storms are actually occurring. So either rain or the combination of rain and snowmelt. Usually snowmelt in California is not enough to cause major flooding on the rivers when they're in the steeper part of the mountains. But the real challenge then becomes downstream, where the rivers flatten out, where the flows accumulate and slow down. And so this remains the case that in the San Joaquin Valley and in the Tulare Lake Basin in particular, but also the east side slopes, like the east side areas where the slopes flatten out, like the Owens Valley and other parts of far western Nevada as well, this snowpack is still enormous. And perhaps 20 to 25% of it has now melted, but that means that in all likelihood, at least 75% of the snow water is still up there. So in other words, the significant majority of what was up there at its peak is still there, even as we head into May, even in the wake of major heat waves. So this melt really is still just getting started. I know that's hard to believe, but we're getting into May, and the peak is probably yet to come. But again, the challenge is that there's essentially no expectation of widespread serious flooding in the mountains or in the foothills. But the real concern remains all of that water, all of those high flows, which will be high but not extremely high in the foothills and mountains, they accumulate in the Central Valley. And it's the very long duration of high flows rather than individual days with extremely high flows that are going to cause continued and still escalating problems in the Central Valley when things flatten out. Again, this is primarily concerned with the Tulare Lake Basin, because that is the downstream of where the snowpack remains the most anomalously extreme, and it's also a place where the water has nowhere else to go. There's already widespread flooding, and again, 3/4 of the snow water that's up there is yet to come down the mountain. So that's still inbound. And things are getting more and more saturated, and there's less and less places for that water to go in the Tulare Lake Basin and surrounding areas. So I still believe that some of the tributaries of the San Joaquin River and the watersheds that drain into the Tulare Lake Basin are all still at conspicuously high risk of worse flooding in the coming weeks. It's currently estimated that the flood risk or at least the inflows, I should say, into these basins will probably peak around late May, early June. That will depend how warm or cool things are. If we get a big heat wave again, it might be earlier than that. And if it stays relatively cool, or cooler than average, as appears to be the case at least for the next week or so, it could actually be delayed a bit further into June. So this is not over yet. Most of the water is still got to come down the mountain, and in places like Tulare Lake Basin and possibly also parts of the San Joaquin Basin, things will get worse still before they get better, even though I don't expect there to be major flooding in the mountains themselves or in the foothills. One caveat there is that if there are any operational problems in the areas or either at or near some of the dams or the dam auxiliary infrastructure in the Southern Sierra, that could change things a bit. And there have been some challenges with some vibrations at power plants on a couple of these dams, I believe. There's not been a huge amount of coverage because it's not a huge problem right now, but there has been a little bit of concern as to exactly what's going on there, and so the Army Corps has rerouted water so that it's not running through the power plants on a couple of these dams over the weekend, so they could check it out. So there is another way to move water out, but they're not currently moving it, I believe, or at least they weren't for a period this weekend, through the turbines. And so this is just an example of the kinds of things that can come up where if you can't spill water as quickly as you want to, you can start to run into problems, and you may have to spill water more quickly once you fix things to level things out, because again, there is a huge amount of water still upstream of some of these smaller reservoirs in the Southern Sierra. So these reservoirs are going to have to turn over 1 or 2 times their full volume in the next month or so still. And so that means they're going to be releasing water essentially at continuously very high to maximum outflows for in the coming weeks. So if anything interrupts that process, then some significant challenges and some slightly larger threats of flooding in different kinds of places for different reasons could potentially emerge. That's speculative. I'm not an expert on exactly what's happening operationally at any of these dams or other infrastructure, but there have been some rumblings about this, and there were some minor issues this weekend, just an illustrative of the fact that you never know when you're not going to be able to release as much water as you'd like to be able to release. And when in this situation like this, where there's just a massive amount of water upstream, and you know you're going to have to be more or less continuously releasing very high flows for the foreseeable future, any interruption in that can become a problem. So it's just something to keep an eye on, although there currently are no major concerns in the short term. So again, the main concern remains the Tulare Lake Basin and really the southern part of the San Joaquin watershed, where things flatten out, where the water accumulates, and where there's not a whole lot of room left for water to go that hasn't already been the low stakes inundations so far. So the stakes are going to continue to rise. There are some small communities either within or near the Tulare Lake Basin that are at risk of flooding, and that includes a major state prison, which is a temporary home to a lot of people. Some of these places are protected by earthen levees that are not designed to an extremely high standard, and so there is concern regarding what happens there as these inflows. Again, they won't be record-breaking inflows, but they're just going to be sustained at very high levels for weeks to come. And that is the problem. It is the cumulative volume that is the problem here, rather than the peak instantaneous flow rates, which again is different than would be the case if we were in the middle of winter seeing major storms, as we were earlier this year. So this is a bit of a different beast in terms of the locations at most risk of flooding and the reasons for that. So I think that, again, as I was mentioning earlier, I think that the peak is definitely yet to come. The majority of the water is still up there. There's still a lot of water frozen into that higher elevation snowpack. And we may not see peak outflows in some watersheds for another month, depending on how warm things are. So I guess that's not too much of an update than last week. Things progressed largely as expected. There'll be a slowdown in melt rates this week as temperatures get much cooler. In fact, there may even be a little bit of net snow accumulation at the highest elevations. I don't think it'll be all that significant from a net snow water equivalent perspective, but it will potentially flatline the melt in some higher elevation regions, even as the melt continues at lower elevations for at least a few days. So I want to talk a little bit more about that system this week. So it's a cutoff low. This is, a very typical type of pattern for May in California. This is usually how if it is going to rain in May, this is usually how it happens, is a low pressure system gets cut off from the jet stream. That's why we call them cutoff lows, and it meanders a bit since it doesn't have any strong steering flow. This one looks like it has particularly cold air aloft. It's actually getting close to some of the coldest air aloft we've seen this time of year. Does not mean it's going to be record cold at ground level, but if you go miles up into the atmosphere, it's very, very cold. And as this air mass moves in this week, it's going to bring a few things. First of all, this does not look like a major storm really anywhere. In fact, some places may stay completely dry this week, but other places might get some decent convective downpours. And that does mean that there is a chance of some significant thunderstorm activity across most of northern and central California, and maybe the northern fringe of Southern California down along perhaps Santa Barbara and Ventura counties, maybe into LA County. Some significant thunderstorm activity could occur. It may be isolated, so I don't think everyone's going to see it, but it could be pretty noticeable if it's in your neck of the woods, because you'll get some heavy downpours, probably some significant small hail. And if you're in the Central Valley in particular during these setups, there always seems to be at least one or two rogue thunderstorm cells that become stronger or even severe, so I wouldn't be too surprised if there were a couple of reports of larger hail or a brief tornadic spin-up somewhere in the Sacramento or San Joaquin Valley, either Tuesday or Wednesday this week. When air aloft is this cold and you have that strong May sun angle, you have quite steep vertical lapse rates, and that usually results in a decent amount of surface-based instability to generate those storms. So some isolated stronger thunderstorms, definitely possible this week. Elsewhere, some occasional showers. In the mountain areas, this may well come in the form of snow above 6,000 or 7,000 feet. Probably not a huge amount of snow, although if you get caught under a convective snow band up at the higher elevations, it could come down and stick to the road really quickly. So there may still be some travel issues. This is, of course, nothing compared to the kind of snowfalls we saw this past winter, as you would expect, because we are now getting into May. But it will still be the first snow in several weeks in some of these places, and so notable from that perspective. And of course, it will be colder this week, so snowmelt will slow down a lot, and it won't be nearly so. It won't be t-shirt and shorts weather anymore for a while across most of California, as these scattered showers and isolated thunderstorms, along with some mountain snow, gusty winds. Good cloud watching week, I will say that much. This is the kind of pattern that tends to produce some really nice clouds in between these bands of showers. And again, I don't think most places are going to see a whole lot of rain or snow out of this, but localized spots could actually see some pretty significant downpours. So it'll keep the vegetation moist for another week or so, which is always nice to see at this time of year. And again, there may be a secondary cutoff low pressure system that sort of dives down this coming weekend. It looks weaker and probably won't extend as far south. Could bring a few more showers to the northern third to maybe the northern half of California, but I think it'll be even shorter lived and less significant. But it will keep colder than average conditions and breezy conditions going, probably at least through this coming weekend. So it looks like we're looking at about a 7 to 10 day stretch of cooler than usual conditions for this time of year, unsettled weather, potential for some showers and maybe some isolated thunderstorms at times, and a bit of mountain snow, and definitely decreased rates of mountain snowmelt over that period. So nothing extremely dramatic, but definitely a change in the weather from what we've seen recently that will be noticeable and could result in some isolated stronger thunderstorms, especially across the Central Valley. Beyond that, it does look like as we get towards mid-May that the cooler than average pattern may relent, and things may warm up again and dry out again. So I don't think this is going to be an extremely prolonged cool pattern like the ones we've seen recently. But I also don't see any immediate indication of new heat waves on the horizon either. So fairly benign weather, definitely some May showers, which don't always happen, but looks like they will this year. And let's see, what else is going on? Oh yes, El Nino. Nothing dramatically new since the last conversation I had with you folks, but the reality is it looks like it's full steam ahead for what now appears likely to be not just an El Nino event, but in particular a moderate to strong event by this autumn. Confidence is now pretty high that this is going to be a big one. Now the question is only how big is big. And there is still a considerable range from about a medium strength event all the way up to the strongest El Nino event we've ever observed in the modern record. So that's a wide range, but the upper end of it, and you could call it the upper tercile or the upper quartile of predictions, are very, very high right now for this event. Do these dynamical models have a tendency to over-predict the magnitude of El Nino at this time of year? Yes, they do, so that's an important caveat. We are still in early May, and a lot of this isn't really going to unfold until later this summer, so it's still pretty far out. But there is a remarkable degree of confidence in these multi-model ensembles, and also there are theoretical and observational reasons to believe the models in this case. So sometimes the models will suggest a rapid strengthening and rapid intensification of El Nino that doesn't really make sense based on the initial conditions that we see. And like, well, maybe, but there's not a whole lot of warm water on the subsurface, and there are no westerly wind bursts in the forecast. No, in this case, there's an enormous amount of unusually warm water across the entire tropical Pacific subsurface. So just below the surface of the ocean, the top 100 or 200 meters or so, there's a remarkable amount of warmer than average water. So that's there. That's already in place. That doesn't need to come out of the ether. That just needs to come to the surface. And it appears that there is going to be a sustained and strong period of westerly wind bursts beginning within the week or so. This is partially forced by a favorable phase of the Madden-Julian oscillation, for those folks who know what that is. But in general, it does look like the atmosphere is aligning and coupling with the ocean to further intensify El Nino considerably during the month of May. So I would essentially think that if the current prediction for a sustained period of westerly wind bursts in the equatorial Pacific Ocean that is currently being forecast for the next 2 weeks to 3 weeks, if that actually happens, then I think this major El Nino is probably going to happen, because everything else is already in alignment. The ocean surface temperatures off the coast of South America, particularly off the coast of Peru, but now expanding in other areas, remain extraordinarily warm in that coastal El Nino event along the coast there. There have been some remarkable rainfall events in Peru and in the desert regions just inland from the Pacific. There are some tropical deserts in that region, and they've been actually pretty wet because the ocean is as much as 10 degrees Fahrenheit warmer than usual right now in some small localized areas right near the coast where there's normally a lot of upwelling, but where there is no upwelling at all right now. It's all just warmer water that's staying at the surface rather than all the cool water coming up from beneath, which is a signature of the early stages of El Nino. We saw similar events occur in 1982, 83, before that major El Nino event, and then also in 97, 98, before that big El Nino event. To a lesser extent in the 15, 16 event. So maybe this is a sign that the current one might resemble a little bit more like the old school big El Nino events of the 80s and the 90s. But in any case, all indications are that El Nino is coming and that it's increasingly likely to be a moderate to strong event, and at the outer end of the possibility is the possibility of a super El Nino event that could rival historical records. That is currently what we see. It's too early to make a specific prediction, but I'm increasingly confident this probably will affect California weather starting mid to late summer and continuing through the autumn and probably into next winter as well. So what will it do initially? I think we will at some point this summer, as I mentioned last time, see a sudden flip from the current below average nearshore water temperatures off the coast of California. Right now they're actually quite cool, not surprising given the persistent northwesterly flow and upwelling we've had recently. That could rapidly reverse itself at some point between about June and July and result in warmer than average temperatures off the coast of California. That would have obviously implications for the marine layer and for immediate coastal areas in terms of being warmer and more humid than usual later this summer. It would also affect the likelihood of heat waves later this season. It would make coastal-based ones easier to occur. It may also slightly increase the likelihood of seeing tropical cyclone remnant events late summer, early autumn in California. Slightly increase the likelihood of some westward monsoonal incursions, not by a lot, maybe a 20 or 30% boost, but hey, it's something. It probably more noticeable will be the warmer than usual ocean temperatures, which will be especially noticeable, assuming they materialize, given how cool the waters have been both so far this season and in recent seasons as well. We've seen some years with pretty cool nearshore temperatures in California due to increased upwelling. That could very dramatically reverse itself within the next couple of months. And then, of course, next winter, all eyes would be on a major El Nino event because it probably would increase the odds of a wetter than usual winter again in central and southern California in particular. This would have major implications if there's still ongoing inundation of places like the Tulare Lake Basin, which could very well be the case heading all the way into next winter as a residual effects from this year. So we're going to continue to watch how that evolves, but I think this is going to be the big story this summer. And it's, of course, going to be a big global climate story as well, because the global oceans are record warm right now. Again, this is in stark contrast to the local ocean off the coast of California right now, which is unusually cool. Almost everywhere else on Earth, it is extraordinarily warm. And in aggregate, it is record warm. All around the ocean basins, all around the world right now. So if this El Nino is a very strong event, it has a pretty high likelihood of pushing us into global record air temperature territory by next year, because El Nino events tend to do that already. And of course, now we have the global warming trend, so we would really have this natural cycle of warming superimposed upon the human-caused cycle of warming at a level that we just haven't seen before. If current predictions pan out. So this will be probably a major story in global climate over the next 6 to 12 months, and California may end up being an epicenter of that conversation given some of the impacts that we would expect from a strong El Nino event here. Major effects, of course, elsewhere too in the world, but I think historically there's just in pop culture for good or for bad, California is definitely part of the El Nino conversation globally. And so if we got a big one this year, I think California is going to be featured prominently in those conversations. All right. I think I'm going to start taking a look at the questions now. Let's see what we've got here. Kat asks or mentions, I'm very curious to know if the groundwater reserves, presumably in California, have been recharged by all the water we've had this year. It's a good question. The answer is probably yes, to some extent. But also, it's not as easy as some folks might assume that it is. Groundwater, of course, is stored in what you would call pore space, meaning that there's some air in between individual soil particles and pieces of rock. That's where the majority of the water in groundwater aquifers resides. It's not in huge caverns, underground lakes filled with water. It's primarily in these little gaps in between the soil particles, which of course individually they're not very big, but when you have, when you aggregate them over cubic miles underground, then you actually have a lot of potential airspace in which water could be stored. That's where most of the groundwater is, in the saturated zone, in the subsurface soil, excuse me. And so when you have a depletion of that aquifer, what happens generally is you lose the water, and that air volume starts to allows the soil and the sand and the rock particles and pieces to compact. So as you remove the water, you suck out the water through your straw being wells, generally speaking, that are pumping groundwater out from the aquifers. You lose that pore space, and the ground itself subsides as the space between soil particles decreases, as you lose that pore space. That is not an entirely reversible process. It is partially reversible, in some places more than others. It depends a bit on the soil and the geology conditions. But sometimes once you've lost that pore space, it's largely gone permanently, to a certain extent. It's rarely completely irreversible, so usually you can resaturate those aquifers, at least to some extent. And I'm not a hydrologist or geologist, so I won't profess to be a real expert in this. But from working with those who are, in California, there are some places that are more resilient to this than others. In the San Joaquin Valley, in many places in particular, and also to a lesser extent in pockets of the Sacramento Valley, where there has been major ground subsidence on the order of feet, and in some cases even tens of feet, of ground sinking over decades, it's pretty obvious you've lost a lot of pore space. And in some of those places, we're not getting all of those feet back. Maybe some of them, but probably not the majority. And so there's a limit to how much water can re-enter the aquifers that way. The other problem is that even if you haven't permanently lost the pore space, it's not as if just pouring water on the surface magically recharges the aquifer. In a lot of parts of the San Joaquin Valley, there's a pretty significant clay layer, which, especially when it dries out, can become a pretty impermeable barrier to water. It can take years for that clay layer to resaturate enough to let water down into the aquifer below, or it requires actively punching through that clay layer in some cases to essentially build groundwater recharge wells. So that layer of clay can inhibit the flow of water from the surface to the subsurface, even if there's abundant water, even deep flooding occurring above it. In fact, this may well be happening in parts of the San Joaquin Basin and the Tulare Lake Basin. Because there is such a impermeable clay layer beneath, you might have 5 or more feet of water sitting on top of a relatively impermeable clay layer and a depleted aquifer beneath it, and it's not going to recharge that aquifer very effectively. So it's a complicated question. There's clearly some amount of recharge going on. I don't think we'll know exactly how much until after the fact, but it's not as much as you might expect because of the damage that's been done to the aquifers and the intrinsic ability of these clay layers to keep water from soaking in. So it's both a problem of anthropogenic origin and also just the nature of the system, where you need to let water sit there for years sometimes for it to, in some of these places, for it to make meaningful progress. That is what would have happened naturally, by the way, is in the really wet years a few hundred years ago in the Central Valley, that water in Tulare Lake would have just sat there for years. Tulare Lake, in its original form, was highly variable in size from year to year, but it was usually there for multiple years in a row, and it was quite broad and relatively deep in some cases, depending on how wet the years were and how much snowmelt there was. So, this is one of those things where these aquifers took a long time to develop, and sometimes this is why a lot of these aquifers have what we refer to as fossil water that is ancient essentially, and went down there hundreds or thousands or even thousands of years ago, and we've pumped it out over the course of just years to decades. So that's one reason why it's unsustainable. It's not just that there's more being pumped out than is going back in, but it's that there's an intrinsic limit on how quickly the water can go back in, unless we do very active things to make that more plausible. So there are things that can be done to accelerate the recharge, and there is lots of conversation about doing that. Active groundwater recharge in California. I think we're going to see more of that moving forward. But the news is mixed, and no. The short answer is no. We've not suddenly recovered our massive groundwater deficits, even though this year probably will be a net recharge year. The question is it a large amount relative to the amount that we've taken out of the aquifer in recent decades? And I don't know the answer to that quantitatively. We'll probably know more once we can take measurements later this year. The NASA Earth orbiting satellites, actually, the gravitational anomaly detecting satellites, might be able to tell us something meaningful about that, because they can tell us a lot about how much water is below the ground, because it actually affects in a detectable way the local gravitational field. You can imagine that a part of the Earth that's got a ton of water in the soil subsurface has more mass associated with it than the equivalent soil column that has very little water. So you can actually detect that as a gravitational anomaly locally from space, and that may well be how we figure that out. Interesting to see in the months to come. Good question. All right, looks like that was also the second question from John, so now I feel better about spending some time on it. A comment from Alex that all reservoirs and lakes above 6,000 feet are still just about frozen. How does that affect the preventative capacity and the overall capacity? I'm not 100% sure what that means, but the higher elevation lakes a lot of them are still frozen over, which is not that unusual for May, although more of them are more frozen and probably more deeply than would usually be the case, because we had in some places the coldest winter in several decades up there. So usually though, the lake isn't frozen solid all the way to the base, so there's still plenty of liquid flowing water underneath the ice layer. In a lot of these dams, these lakes that have dams on them, and so are reservoirs in some capacity, usually those outflows are below the surface, and so they're tapping the water that is unfrozen, I would imagine, in most cases. So I can't be 100% certain that's true in all cases, but usually I don't think it's affecting the reservoirs, the dam operations that much at the moment. I will say, though, it's an indication that there is still a lot of that the deep frozen snowpacks are a considerable heat sink still. This is why they haven't melted more quickly yet, because even with this heat wave, the middle of the snowpack is still really cold and icy and frozen solid. So it's going to take time for the sun's energy and the thermal energy of the warming atmosphere as we go from spring into summer to really do that work. So we still got weeks to come before the peak, probably. All right, let's see here. Question from Mike about whether the snowmelt is accelerated in presumably wildfire burn areas in the Sierra Nevada due to direct sun shining on the now exposed surface. All research points to yes, that there are major modifications of the hydrology and the surface snow climatology in places that have recently experienced fire, particularly places where the fires have been intense enough that they've removed the tree canopy. So there's two things that happen. One is obviously if you have a dark surface because things have been charred and burned, that changes what's known as the albedo, the reflectivity of the surface, darker ones absorb more energy directly from the sun versus lighter surfaces which reflect a lot of the sun's energy. That's a lot of that's intuitive. It's one of the reasons why blacktop paved surfaces get so hot at the surface in summer under direct sunlight. But there's also the other effect is that if you've killed the trees, so again, the effect is stronger in high intensity burn areas. In low intensity burn areas where most or all of the trees survived, the effect is mainly temporary and through that darkening albedo effect, where there is some effect in that direction. But in high intensity burn areas where you've killed the trees and you've largely lost the tree canopies, these trees are no longer living, actively transpiring plants, then what can happen is you also lose the downward sort of the shading effect of the tree canopy itself. So previously, it's not just that the surfaces were darker, but it's that the sunlight would be intercepted by the tree canopies and wouldn't even make it to the surface anymore. But now, in some of these places where we've seen large-scale high-intensity wildfire burn areas, we've lost not only the reflectivity of the surface, but also the canopy itself, and so more of that sun is making it all the way directly to the surface. So folks have attempted to quantify this. No one's done it for this year specifically, but yes, this does have an effect. And given how large some of the fires have been in recent years and how large the high-intensity burn portions of those fires have been in recent years, then yes, I think this is probably a hydrologically significant thing. And it may become more important later this season as certain patches start to melt out. So right now, there's still a lot of contiguous snowpack. There was just so much snow that there's still a lot of just white on the ground. But as the sun starts to do its work and as the snow starts to become patchier and exposes more dark black ground in between the snow patches, then this process might well accelerate in the coming weeks. That's just a hypothesis on my part, but it's informed by a lot of research in that area. Question from Mark about whether the upcoming El Nino is looking different from a Madoki type El Nino. Just for reference, that refers to it's a Japanese word, derived word, modifying a Spanish word. So it's quite the interesting historical context of different scientific endeavors in an international collaborative context. But excuse me. Now, El Nino Madoki is essentially a Central Pacific-based El Nino event. So that's the term for El Nino events where the maximum anomalous tropical warming is closer to the Central Pacific as opposed to the Eastern Pacific. This year, and they do have different teleconnections, so different geographically remote effects on the water cycle than the other form. Right now, this is looking like very much like a traditional East Pacific centered El Nino. So in other words, the ones that seem to be most likely to affect California precipitation. But that's a prediction, and we'll have to see what happens. Sometimes the model don't get that spatial orientation quite right. Right now, it looks like it's going to be a pretty east focus, so not a Madoki type event, but we will just have to see how that evolves. Either way, I still think that there's a good chance that it's going to affect California weather in a similar way, but the degree to which that's true probably will depend on the east-centeredness of it versus the central Pacific-centeredness of it. And at this point, it looks like it's more likely to be east-based than central-based, but we don't know for sure yet. Question from Jack. Folks have been saying that the negative phase of the Pacific Decadal Oscillation, the PDO, may kneecap this El Nino event in terms of big winter effects. Do you have thoughts on how the PDO and ENSO interact? Yeah, I have thoughts on that, some of which are probably a little bit controversial in certain circles. But I think that mainly, what is the Pacific Decadal Oscillation is the first question. And the answer, in a very narrow sense, is it's a statistical construct. A lot of folks increasingly believe that the Pacific Decadal Oscillation is really just a long-term, time-aggregated, essentially product of El Nino and La Nina variability. It's different expressions of Pacific variability in a coupled ocean-atmospheric sense that come largely from long-term variations in the occurrence of different types of El Nino and La Nina events. Is that entirely the case? Maybe not. Maybe there is something more intrinsic to it. But ultimately, the reason why it matters is because essentially it's saying is that the spatial distribution of tropical ocean temperatures anomalies aren't the only thing that matters. That it's those in combination with some particular ocean temperature anomaly pattern in the extratropical Pacific, so outside of the tropics, in this case in the northern Pacific. And that's of course true. It does affect the teleconnections, but the reality is the main reason why ENSO and El Nino in particular affect Western hydroclimate at all is because they generate what are known as Rossby waves, anomalous Rossby wave trains over the Pacific Ocean that originate in the tropics and propagate into the mid-latitudes. And it really has to do with the longitude at which those anomalous Rossby waves are generated. The reason why strong El Nino events are associated with wetting of the southwest hydroclimate and drying of the Pacific Northwest, at least in the canonical traditional sense, is because it sets up a Rossby wave train that favors an unusually persistent and deep low-pressure system in the Gulf of Alaska that sort of slings winter storms towards California repeatedly and the Southwest repeatedly and strengthens the subtropical portion of that jet while weakening the polar jet, the subpolar jet, farther to the north. So it essentially, it's a kind of a subtle shift, honestly, in the overall wave pattern over the Pacific, but it's, of course, subtle shifts mean a lot regionally, and in California and in Southwest, that's the canonical shift. That's the primary reason why strong El Nino events are historically associated with wetter than average conditions, and why we would expect that to be the case in the future. But there are, of course, other things that can modify that teleconnection. In 2015-2016, we had a strong El Nino event that was not an exceptionally wet winter in California because other factors interfered with that El Nino response. We can't guarantee that won't happen again, but we can also say that if we do get a strong East Pacific centered El Nino event, that it's very likely that we're going to see that Gulf of Alaska low pressure response, and something pretty significant would have to come along to disrupt it. So it's a long way of saying, yes, the extratropical Pacific matters, but the tropical Pacific matters more. And if we get a really strong East Pacific based El Nino event, I don't think that the state of the PTO or other things are super likely to override it. I think it would likely be the dominant effect next winter. Is that an absolute prediction? No, but that's currently my best estimation. We can revisit that, I think, in the months to come as this develops. Question from Roger: can we expect extreme heat and or low humidity events this summer along the Central Coast? Well, it depends. Early in the summer, so the May gray and June gloom might be enhanced this year. They could actually be cooler and foggier than average along the coast, at least to start, because currently there's a lot of upwelling and ocean temperatures are cooler than average, so it's going to take a while to get out of that. But as I mentioned earlier, at some point this summer I would expect that the nearshore ocean will warm pretty dramatically due to, among other things, the potential for coastally trapped Kelvin waves emanating up from the tropics thanks to El Nino. And so I think that we may go rapidly from very cool and gray conditions in May and early June, which again are typical but maybe even more enhanced than usual this year, to later in the summer a sudden flip of the switch to much warmer than average conditions along the immediate coast and more humid and warmer conditions. So probably not necessarily more likely to see low humidity events this year. I actually think that seeing very low humidity heat waves this summer is somewhat less likely than we've seen recently because A, there's a lot of moisture across the mountains and in the Central Valley in some places because of all the inundation, and B, as we transition towards warmer ocean temperatures along the coast, that would also make very dry conditions less likely to occur along the immediate coast. Doesn't mean it won't happen. Sometimes we get synoptic scale weather patterns that favor it anyway, but I actually think that higher humidity heat waves are perhaps more likely in the second half of summer than usual, both due to the potential for warmer than average nearshore ocean temperatures in July and August, and also the higher levels of soil moisture from the melting snowpack and from the wet winter than we've seen in recent years in the California interior as well. So Hopefully that answers that question at least to some extent. There's a question from John about speculation that having the presence of Tulare Lake and having water in it would add in some way to would augment Southern Sierra precipitation in itself, and whether this happened in the past. Is this conjecture or is there actual evidence? Well, it's an interesting question. I think it's mainly conjecture, but it's probably informed conjecture. I'm not sure anyone's ever actually done a study on this. But there probably is at least some minor enhancement of precipitation in the Southern Sierra if there's a semi-permanent body of water immediately upstream. It's less so than would be the case in other places, though, because in California the majority of precipitation comes from moisture-bearing Pacific storms in winter. They're not moisture limited, really. They're dynamics limited rather than moisture limited most of the time, and so we have an infinite reservoir of potential water to evaporate over the Pacific, right? So usually that's not the main limiting factor for precipitation. That's not so true in continental regions. So if you're in the central U.S., for example, having more water in the soil or bodies of water nearby does significantly increase precipitation because you get it mainly in the form of afternoon thunderstorms in the spring and summer, and so there's a lot of direct local precipitation recycling, moisture recycling that goes from the land to the atmosphere and back to the land via precipitation in those kinds of places. California generally doesn't get a lot of that, with the exception of the summer monsoon season, and there is some monsoonal thunderstorm activity in the mountains in summer, and in such cases perhaps there is a plausible link toward a slight augmentation of precipitation under those summer conditions if there's a nearby water body like Tulare Lake near the Southern Sierra. So in a limited sense, I think it's not unreasonable, but it certainly doesn't result in large average changes to average precipitation or fundamentally alter the climate of the region. It's less. It might in a different climate regime, but we don't have the right kind of climate regime in California. We don't get enough of our precipitation from warm season convection generally for that moisture recycling component to be super important, with the exception that there probably is some minor component in summer where that might matter. All right. Well, I think I've answered most of the questions, at least in some form. So I might cut this one a little bit short in the interest of getting back to my email inbox this morning. Do watch out, though. I have an interesting announcement about something that I've created that you can actually go online and buy in the near future. It's an extreme weather and climate calendar that I think is going to be going on sale imminently. So I have to talk to the publisher, figure out the details, but if you're interested in that kind of thing, as I suspect that many of you are, stay tuned for that announcement coming up later this week. So with that, I think I'll call it a day. And thanks, as always, for your continued engagement. I will say that these sessions have been really popular. I've gotten a lot of positive feedback for them, so I think I'm going to make them a permanent feature. So I'll continue moving forward. Not totally sure exactly what the scheduling will look like, but probably try to announce them at least a few days in advance on regular occasions, and then occasionally we'll do some last-minute ones as events evolve. So I may try doing them again at different times of day to accommodate some other folks, although, of course, you can always view them after the fact because these will remain recorded and will be available for as long as YouTube is still around, so I'm guessing that's going to be for a long time. So I'm glad these have gone well. I'm glad these have been useful for folks, and I've come to enjoy them too. Eventually, I also want to put out some pre-recorded content in the form of interviews. There is one that you can view right now with the authors of that very interesting research on the extraordinary Pacific Northwest heat wave of June 2021. You can look in the video section for that one. I would like to do more like that. They're a little more time consuming to produce since I've got to wrangle everybody into the same virtual meeting at the same time and then do some editing. So they're not quite as spontaneous as these, where I can just hop on and talk with you folks, which is a big part of what I like about these live sessions. But do stay tuned for more stuff like that in the future. It won't be nearly as frequent as these live sessions, but periodically I will come out with stuff like that as well. All right, I think that's about it for today. Thanks for watching, and see you next time.